Hello, this is section 5.3, Annuities, Present Value, and Amortization. Now, um, in section 5.2, we studied annuities where regular deposits were made, so that the value of the annuity increased from $0 at the beginning to some future value at the end. Now, um, with this lesson, sometimes annuities begin with an amount of money and make regular payments out each period until the balance decreases to $0. Examples are lottery jackpots, structured settlements such as from an insurance payout, or court settlement and trust funds. So that's what we're going to be talking about. Um, Present value of an annuity is the amount that must be deposited today to provide all the payments for the term of the annuity. It doesn't matter whether the amount needed is to accumulate funds or to disperse funds. So this is the formula for that present value of an ordinary annuity, and we're not going to be using this. Again, you can see the same. PV is present value, PMT is the payment at the end of each period. We've got I, which is the rate divided by the number of periods per year, and then we have our N, which is the total number of periods. Okay, so let's look at an example here using this. Camilla was in an auto accident. She sued the person at fault and was awarded a structured settlement in which an insurance company will pay her $2,000 at the end of each month for the next 7 years. How much money should the insurance company invest now at 4.7% compounded monthly to guarantee that all the payments can be made? Um, so at the end of each month, that word right there means that this is an ordinary annuity. Um, so our the PMT is going to be the $2,000. This is the time, which is 7 years. Rate is 4.7%, so that is 0.047. Compounded monthly, so we have M equals 12. And now I will be 0.047 divided by 12, which is 0.03967, and I need another 0 here. So it should be 0.00. And N is 12 times 7, which is 84. Okay, so let's go ahead and plug the numbers in. 2000 is our PMT. 1 minus parentheses 1 plus, and then I'm going to leave the I as this. It's just, I mean, yes, you can, if you want to, use the decimal as well, but right now this seems a little bit more accurate. If you struggle with the calculator, use the decimals, or use the decimal 0.0039167. This is to the power of negative 84, and then all this is divided by, again, I, which is 0.047 divided by 12, and that is brackets. So again, we need to be careful when we plug this in the calculator. Um, yeah, you need to, the innermost parentheses first, and then remember that this line right here acts as if it is if there's parentheses on top of it and a bottom of it. So 142,924 $1,000.79 would be the present value. Okay, next. We have to supplement his pension, Hong plans to use $400,000 of his savings as an ordinary annuity that will make monthly payments to him for 20 years. If the interest rate is 5.2%, how much will each payment be? How much will each payment be? So we are asking now for the PMT here. Just checking that, is it on the formula sheet? So PV is the four, so that's the present value, $400,000, and our T is going to be 20, and which is 20 years right here. R is 5.2%, so 0.052. M is going to be the amount of times, and it's monthly, so that means that there's 12 payments made. I is 0.052 divided by 12, and then our N is going to be 20 times 12, which is 240. Now, when we are calculating the PMT, the formula for that is going to be the present value divided by 1 minus 1 plus I to the power of negative n divided by I, and all this inside parentheses, or brackets actually. That should be a bracket. That did not look like it. And that is an I. Okay, so all this comes from this formula right here. We just solve for the PMT. Okay, so we're going to plug in the numbers, and let's see if we have enough room here. 400,000 goes up on the top, divided by 1 minus parentheses 1 plus our I is, that was not calculated, 0.052 divided by 12 to the power of negative 240, that's our N, divided by, again, 0.052 divided by 12, and all this inside brackets. Okay, when you plug this in the calculator, it's going to give you $2,684.22. Okay, let's look at loan amortization. So bank looks at repayment of car or house loan as an annuity that has you paying the bank a fixed amount each month. PV is the principal, which is the amount you borrowed. Okay, amortization payments. Um, Again, a loan of PV dollars at interest rate I per period may be amortized in n equal periodic payments of PMT dollars made at the end of each period where this is, or these two are um, the formulas. Okay, so example. In order to purchase a home, a family borrows $184,000 at 3.2% for 30 years. What is their monthly payment? So our present value is going to be $184,000. The rate is 0.032. Time is 30. So how many payments are there? It's monthly, so there's going to be 12 in a year. And our I is the rate 0.032 divided by 12. And our N is the M, 12 times the time, which is 30 years, and that is 360. Okay, so our payment, PMT, and we're going to use this right here, is going to be the $184,000 times 0. Or no, hold on a second. 0.032 divided by 12 divided by 1 minus 1 plus I is 0.032 divided by 12 to the power of negative n, so negative 360. Now, again, when you are doing the calculations on a calculator, make sure that this is all inside parentheses as well. Otherwise, the calculator is going to think that you're only dividing by 1 and then subtracting the whole thing from it. So your answer will not be correct. So your PMT is going to be $795.74. So that is your payment. So now if we look at this was the question, what is the payment? Monthly payment. If we go and look at what is our total payments plus interest, so $795.74 times 360, because that's how many payments there are. That comes up to $286,466.40. And the amount that was loaned was 184,000. So the interest paid here would be, again, we take this number here and subtract it from how much they borrowed, and we get $102,466.40. That's a lot of money spending on interest, just if you think about it. Okay, so next we're going to look at this example here. So in October 2016, the average rate for a 30-year fixed mortgage was a 3.3%. Assume that a down payment of 20% is required on a home purchase of $285,000. Now, the down payment means that 0.2 times $285,000, which comes to $57,000, is the money that is paid at the time of the purchase. So that money is not financed. So when it's asking for how much money is being financed, which is going to, that's our, the present value, it would be 285,000 minus 57,000, which is going to be $228,000. So this is the amount that's going to be financed. Now, we're going to use that to find the monthly payment needed to amortize the loan. So our time here is 30 years. Our R, the rate is 0.0337. It is going to be a monthly, so there's 12. So PMT equals 228,000 times 0.30337 divided by 12 over 1 minus 1 plus 0.0337 divided by 12, this to the power of 360. When we plug that in the calculator, we get $1,007.35. So that is the monthly payment. Now, the next question is, assume the loan is paid as scheduled after 10 years, approximately how much is owed on the loan. So we need to figure out how many payments are left. So 20 years is left because this is after 10 years. So 20 years is still left. 30 minus 10 is 20. That would be 240 payments left. So what we're going to do now is we're going to use this remaining balance. So if a loan can be amortized by end payments of PMT dollars each at an interest rate I per period, then the approximate remaining balance B after X payments is this. Now, notice that there's an N minus X here. So the N minus X is the payments left. So we're going to use this to calculate the remaining balance. Our PMT is this right here, so 1,007.35 cents. And then our I has not changed. That's the 0.0337 divided by 12. Our N is still M times T, which was 12 times, hold on, 30, which is 360. And then our X is 10 times 12, and that is 120. And now N minus X equals 360 minus 120, which is 240, which we already calculated here. Okay, let's plug the numbers in. So B, 1007.35 times 1 minus 1 plus I is 0.0337 divided by 12 to the power of negative 240 divided by 0.0337 divided by 12 and a bracket closed. When we plug this into the calculator, we get $175,710.23. Okay, so if we look at that number now, and we look at this was how much was financed. So 228,000, and the remaining balance is 175,000. Um, so they have paid off $52,289.77 when we go and um, subtract this 175,710 from the financed amount. Okay, so now we're going to look at amortization schedule. So we're going to calculate how each of the first three payments is applied to the loan above. So how do they go? So what happens here? Our first payment is going to be the 228,000 times the rate, which is 0.0337, and this um, times 1 over 12, because we do 12 of these in 1 year. So it's, hold on, let me do this again. Sorry. So we're going to be using the formula I equals present value times the rate times time. Okay, let's start this over again. Sorry, $228,000 is our present value. That's what we started with. Our rate is 0.0337, and that the time is monthly, so 1/12. This is going to be $640.30. So that is our first interest here. Now, what we're going to do next is we're going to take the monthly payment, which was over here, this amount right here, 1,007.35, and we're going to go ahead and actually, you know what? Let me do it here. 1,007.35, subtract this, the interest permit, $640.30. So we get $367.05. That is going to be the principal that we are paying. So this plus this equals the monthly payment. Now we need to calculate our loan balance. So we started with a loan balance of $228,000. What we're going to do is we're going to subtract um, one monthly payment from it. So our monthly payment is going to be, or the loan balance is going to be $228,000 minus $1,007.35. And that is going to be $227,632.95. So $227,632.95. And now we're going to move forward with the next one. So number 2, payment number 2, we're using the same formula again, but now our present value is going to be this. So it's going to be $227,632.95. Our rate does not change, and it's still a once a month. So when we do this calculation, we get $639.27. That again is our interest here. So that is the interest we're paying. Now, the principal. So every month we are paying $1,007.35. But the amount of interest from this $1,007.35 is going to be different, and the principal is going to be different every single month. So for this month, it's going to be $368.08. And then we're going to again subtract. So we're going to take $227,632.95 and subtract the monthly payment, $1,007.35 from that. And we have $227,264.87 left. So that is our loan balance. So what happens here is that the loan balance, we take out each monthly payment. And the monthly payment is the same. What's different is how much of it is interest and how much of it is principal. So you can see that the interest is kind of going down, and the principal amount of that monthly payment is going up. So as we pay the loan, we're paying each monthly payment is going to have more principal paid and less interest paid. Okay, so let's calculate that third one here. So our starting value is going to be this $227,000, 264, no, $227,264.87. And then our rate did not change, and it's still 1/12. Um, so when we do this calculation, we get $638.24. So see how this is still decreasing. Now, again, our monthly payment is the $1,007.35, and we're going to subtract this interest part from it to find how much are we paying principal in that third payment. And that's going to be $369.11. So that is still increasing the amount as we pay the payment. So we're paying more and more from the principal amount. And then we're going to calculate the loan balance. Again, $227,264.87 and subtract the monthly payment, $1,007.35 from it. We get $226,895.76. So that goes over here. And we can see um, this, obviously, because we're paying it off every month, it's going down, it decreasing. Okay, there are amortization tables and calculators available, but this is basically how it goes. So the faster you pay it off, the less interest you're going to be paying. All right, so let me know if you've got any questions. That's it for today. Bye.